All right, I'm gonna go over daily problem 1.2. Well, the problem is I think there were two daily problem 1.2. So let me see. The first one was evaluating limits algebraically. So Sarang, if you're watching this and you're like, oh, that's not the one that I wanted you to do, write me an email so that I can record the right one. It always shows like this on Canvas app. So I'm gonna go ahead and I think you're talking about the continuity one because that's the most recent one. So let me download the continuity. This is the one that's due this weekend. So I think you're talking about this one. Alrighty, let me go over daily problem 1.2 continuity in this video with you. This is for my Math 261 Applied Calculus 1 class. Alright, so is the function f given by f of x equals, here is a piecewise function. I got two pieces. So what's going on over here? To the left of, oh, that's too big. That's too big. Let me fix it. Orange pen. This is good. To the left of 3, use this piece right here. Use 1/3 x plus 4. Okay, anything smaller than 3 or equal to 3, that's what it is. I'll use this piece 1/3 x plus 4. And the bottom one is saying what? X is greater than 3. So this is the graph. This is the function that will be used for the right of 3 or any number that's bigger than 3. So this is the, but why am I using this? Why am I calling these right and left? Because I'm gonna talk about the left hand limit and the right hand limit in part B. So to the right of 3, I'll just say that. That's to the right side of 3. So I'm asking you to determine whether this function is continuous at x equals 3. Okay? And I'm asking you why or why not. And I made it into 3 parts because I want you to use a definition of continuity that we talked about in class. So first of all, A, you need to find the function value at x equals 3. Does it exist? Let's see. Let me see if I can pause recording. Let's find f of x. Notice x is, which piece do you have to use? It says x is less than or equal to 3 right here, right? So don't plug it into the bottom piece. You have to plug in this 3 into the top piece. There's only one piece that you're allowed to plug in, not both of them. Just plug it into the top piece to evaluate this x equals 3. So if I plug in 3 in there, I'm going to get, this 3 cancels out. 1 plus 4. I got f of 3 is equal to 5. I evaluated the function value. It is defined at 3 and the function value is 5. Okay? Now the second thing, we need to find the limit of x going to 3. And since this is a piecewise function, guys, we need to make sure that the left-hand limit and the right-hand limit are the same for the limit at 3 to exist. So what you're going to do first is find me the limit of x approaches 3 from the left, okay? So that is going to be plugging in the number 3 into the top piece, right? This piece right here, because that is what we're using for the left of 3. So show me that you're going to plug in 3 into this expression. So if I plug in 3 in here, same thing will happen. Because I use the same expression for, hold on, I'm applying to my spring semester. I'm going to read this email later. I'm sorry, I'm so distracted. I'm going to go ahead and do this problem. So that will be 1 plus 4. So the left-hand limit is 5. The left-hand limit is 5. I'm going to now find the right-hand limit. It better come out to be 5, I hope. So if I find the right-hand limit, this time, don't plug in 3 into the 1/3 x plus 4, but you need to plug that into 2x minus 1 this time, because that is what the graph will do to the right side of 3, right? So if I plug in 3 in here, that will be 2 times 3 minus 1. That is 6 minus 1. Yay, it's 5. So did you just see that the left-hand limit and the right-hand limit, they are the same? So because they are the same, and because I'm doing this, I'm going to go ahead and just make it all extra. Since limit to the left of 3 of f of x is equal to the right-hand limit left and right, limits are the same. The limit exists. And it is 5. Yay, we found it. Now, compare the answer that we got on part A. F of 3 was 5. The function value at 3 is 5. The limit at 3 is also 5. They are the same, right? And this is what we needed. This is what we need to determine whether a function is continuous at this given point. So the question is asking, is f continuous at x equals 3? And I'm telling you, compare your answer from part A and B. Show that f3 equals limit at 3. And we just saw that they're both 3, right? So I'll go ahead and say it. Since f of 3 equals limit at 3, and they're both what? 5. They're both 5, right? F is continuous at x equals 3. Who knows, on your exam 1, you may get a problem where they are different. So if they're not the same, then you're going to have to tell me it is not continuous at x equals that value, okay? So hopefully this is the one that you talk to me about during class. If it's not the right one, email me. I will go ahead and record another one. Let me go ahead and post this and get to the other one.